Hi, everyone. Thanks for joining us. Our topic today is Python for data science. I'm going to give you an overview of the technical training course that Enthought does with that name. So my name is Mike Connell. I'm Vice President of Training Solutions at Enthought. I'm going to spend a few minutes just telling you who Enthought is and what we do, and then I'm going to spend most of the time giving you the overview of the Python for data science course. We'll have a little bit of time, hopefully, for Q&A at the end. But if you have questions during the presentation, feel free to type them into the questions box, and my colleague Courtney will respond to them if she can. Otherwise, we'll batch them up for the end. And just a note that everyone who registered for this live session will also receive a link to the recording. So who is Enthought and what do we do? It's easiest to kind of show you rather than tell you about that first. So we do what's called scientific and analytic computing. And as an example of that, we work in the oil and gas industry quite a bit. And so they've had scientists, geophysicists, and they're collecting data, right? You can't just look and see where the oil is. You can't just drill all over the place to find it. So they do seismic readings and they drill core samples and pull up some actual rock samples and look at that. They CT scan those and they have the digital version of that. They do photographs of the borehole and so on. So they have a lot of different kinds of data. And, you know, historically they would give that to their geoscientists and they would look at it and they'd study it and they'd try to infer where the oil might be and how much. Part of the challenge is that it's not a clear picture. A lot of different rock structures and kind of oil configurations can give the same looking pictures, so they really have to do some sleuthing. So one thing we do is we go in, for example, we'll work with their scientists and we'll even go to the literature, and together we would come up with the latest rock physics models and develop some algorithms so that they can, for example, simulate different scenarios under the ground and see what kinds of imagery those would produce and then compare it to their own. So that's a new capability, right? They can do it in a different way than they would have in the past. In addition, as you can kind of see through this little interface here, we would bring together a set of tools that are custom to their workflow. So, you know, what kinds of visualizations do they want? What kinds of manipulations do they want to be able to do to the simulations and so on? So that's fairly typical as we bring new capabilities through the combination of their science and software. And we also bring workflow tools, which can sometimes speed up. Sometimes the work will take weeks or even months, and we can speed it up to days or even hours. It's kind of another example. Working with a Wall Street firm, they wanted to develop a model of their overall portfolio risk. So they have all these different investments, and they want to track their risk of their portfolio given current market events and conditions. And so we would work with them again and look at the literature to find the latest financial models. And then we'd use that to build a set of models and tools for them that exactly fit their need. So that's what we call scientific and analytic computing. It's a combination of software and hardware and research and engineering or design. All right, so we've been doing that for over 15 years. We're a global leader in that kind of scientific and analytic computing. And we do not only consulting, but we also we have a set of software tools that we provide which make it easier for organizations to do that kind of work. We provide training along with that a lot of times, but also for people who just want the training a la carte. And then the same way that Red Hat provides support for Linux, which is open source, we provide enterprise support for Python. Which is open source. So you don't have to have a team internally that's keeping track of all the packages from all the different providers and testing them and putting them all together and so on. We do that for you. So we have a large user base. We have over 1 million user downloads of our software. We're headquartered in the US in Austin, Texas, but we do have a global reach with offices in Cambridge in the United Kingdom and Mumbai, India. So real quick on this slide, we do consulting in a wide range of fields, as you can see on the right-hand side here. We saw a little oil and gas and finance example, also aerospace, biotech, semiconductors, manufacturing, consumer products, and so on. We do a lot of different fields. Software and support, we provide a Python distribution, which makes it easy for people to use Python and maintain it. So you don't have to, like I said, have that internal expertise or support or cost. We also provide the tools on top of that for doing the work, the analysis work, and then we have some additional kind of plugins and some commercial software for the oil and gas industry. Mainly, we want to talk about training today. We have two kinds. We have open classes where individuals can go and register, and there will be a class in New York or LA or wherever we've put it, and individuals or small groups can go register and attend. Or if you've got a group on site that wants it at your company or your organization, we can go right there where you are and teach it there. We have online training, Enthought Training on Demand. We've done virtual training, which is delivered live but over the internet. And then the gold standard, of course, is live training, and that's the bulk of what we do. And I've talked about most of these classes in other webinars, so I'm going to talk about Python for data science today. All right, we often get questions about our approach and our philosophy about training. My own background is in learning science. I studied artificial intelligence and cognitive science, as well as education. And so that's really my orientation that I bring to this work is, how do we take what we know about the biology and the psychology of learning and turn that into usable principles that make for better learning experiences? So our emphasis really is on the learning and in particular developing transferable skills so that when people leave our trainings, they can go back to work and use what they learned pretty immediately without a whole bunch of digging around to fill in the gaps. We don't have time to go into any sort of technical treatment of that, but let me just give you a little bit of sense of that. So one principle is that learning takes time, and humans can only learn it at a limited rate. You can't just blast them with information and expect them to retain it all. So there's really in a given amount of time, like a day of training or a week, there's a fixed amount that you can learn. Now we could do 100 concepts in a day. We could stuff a lot of actual content, but then we'd have to cover it very thinly. We could define it, maybe we could show a quick example. So at the end of the day, you feel full, but you don't necessarily remember it, it leaks away. Or you could cover a few concepts in depth in the same amount of time. And so there's this trade-off. And it's, you don't necessarily want to go to either extreme. What we shoot for is we want to give you a well-curated, coherent set of concepts that provide the new capability you're looking for, but that develop that knowledge at a level of skill that's kind of pushing toward transferable skill, or reaching transferable skills. Like I said, you get back to work and you can use it immediately on Monday morning. And similarly, when you're doing there are different brain systems that handle different kinds of knowledge. So concepts and skills are stored in different parts of the brain and different kinds of networks. You can't learn to ride a bike by watching a lecture, and you similarly can't learn to program a computer by watching a lecture. So because we focus so much on skill, that 40 to 60% of our classes are interactive, hands-on, learning to apply the skills. Okay, so that's our orientation and approach. Let's talk about the course. This is kind of a bird's eye view of the main structure of the course. The dark blue is the first 3 days, and that's what we think of as kind of the essential tools for people to do scientific and analytic computing in Python. And then the last 2 days is in light blue, and that's the tools that are specific to the data science and machine learning. So in terms of prereqs, there's no Python experience required coming into this course. We provide everything you need there. You should be comfortable with very general programming concepts, like what's a variable, what's a loop, and what's it for, what's a function, and how do they generally work. You could have picked that up from another language like C or Java or Fortran, or another tool like R or SAS or MATLAB, or maybe even a macro language, well, VB or VBA or some macro language where you, for Excel or something. It's just really very low level. It just helps if we don't have to get down to the metal and explain all those very basic concepts. This is one of our more advanced courses, and it's pretty intensive. So we can't teach you, obviously, in 2 days everything about machine learning, all the background theory and stuff. So we assume that people coming in have been exposed to stats. You know what a mean is, you know what a standard deviation is, and so on. And that you generally understand kind of what machine learning is about, and that you have had some experience with data analysis. So it's pretty low level again, but you should have that orientation. That helps a lot. All right, who's it for? Well, so one of the interesting things about Python is that it can be used for lots of different purposes. People use it for web app development. You can use it for system administration, obviously for writing commercial software, software engineering. But we're focusing particularly on the people who use it for modeling and analysis, right? Scientific and analytic computing. And the emphasis in this particular class is on interactive or exploratory analysis, like data scientists do, and especially people who want to use machine learning, because that's a big chunk of it. So, this is in contrast to somebody who, for example, wants to automate an engineering process that they've been doing manually. The Python for Scientists and Engineers class would be better for those folks, because the tools are different and the kind of skills that you need are different. Or for somebody who's not doing machine learning but is doing heavy analysis, then the the Python for data analysis class might be better. Okay, and so more specifically, if you want to think about the people who come in and have a good experience, okay, so we see lots of people like this, and they all do very well. So we collect data frequently from our users to make sure like we have what we want to happen, and then we want to validate that it is happening. So let me just share with you a couple of, I guess, proof points from people who've gone through it that we use to validate that we've hit the mark. So this first one's from someone who's a beginner, right? No computer programming background, no Python background. And they said that the course was very effective, right, for them. After the 5 days, they were able to work in Python effectively, and it provided the foundation in data science that they needed. You know, an overall fantastic class. And then, so that's for folks who don't, you know, the bar is pretty low. You just need to be able to track the computer science topics and so on. And then for folks who've been working in another tool like R or SAS, presumably that person is doing, you know, data analysis, if not data science. They said that this really got them over the hump, and they finally understand Python, and they have the tools to really harness it. So this is to validate that those, in fact, are the audiences that when they come out, this is the sort of experience that they report on. All right, so let's look at each module. I had feedback on previous webinars that people would like more detail on some of the actual content, so I've put a lot of that in here, and you know, given the time, I'll cover as much of it as I can. Okay, so Python language. There's the tools. You got to get your environment set up to that, and then their language. We've divided into the 3 main areas that everybody needs to know, no matter what they're doing: data structures, control flow, and organizing code. Okay, so if you go to python.org and you just download Python, you're not going to get a version of it that's optimized for this kind of work, right? So there's this enhanced interactive shell, IPython, and that's what we use in the training, and we provide it as part of the training package. And it's got some nice additional features, like the documentation is better for this kind of workflow. You can look, because you're always having to look up parameters of packages that you're using for your analysis, so it makes it really easy to kind of pull that up. It has this input-output format where you can kind of see your inputs and outputs, and that allows you to easily kind of go back and pull. You can actually go back and say, give me the output from step 4. So it makes it easier to do this kind of work compared to the regular shell. So we introduce that. And then the Jupyter Notebook is kind of like a math, what is it? Some of these other, like Maple or something, have these notebooks where you can type your code or your equation, and then you can immediately on the line below, you can see the result, the graph or the data or whatever it is. And so what's really nice about that is if you're doing repeatable science, or you want to share this with a colleague, or you want to make it a supplement to an article to show exactly the steps that you did to get to your result, or even if you just want to take a snapshot and archive it for yourself so you can get back there, the Jupyter Notebook is great for that. The command line, it's interactive. It's harder to kind of see all. You can't see all the state. You know, you may have graphs and figures all over the place, and they're not in line. So it's really terrific for that. And so throughout, right, the way we help to develop the skill and make this transferable knowledge is we have what we call these finger exercises. So we'll give you a lecture, and then immediately we'll give you a finger exercise, and that's meant to be like a 3 to 7 minute exercise that makes you apply the skill. And so the instructor can walk around and observe and give help. People can make sure that they understand and ask questions. If they don't, the instructor will debrief, so you'll make sure you get any of that clarified. And the instructor also uses it to gauge kind of how to pace the class and where people might have sticking points and where to spend more time and stuff. So these are essential to the design in order to achieve the learning objectives. All right, so the Python Notebook is great for what it's meant for, but if you're automating a process or doing a simulation, it's not probably the right tool necessarily. So we have a script editor. We show you how to use that, and we provide it as part of the course. And then I mentioned, you know, Python's open source. There's a lot of different amazing packages, but they come from a lot of different providers. And so we provide a package manager. And if you don't like the command line, you'll love this graphical package manager. Not only does it allow you to pick and choose which packages to install for the work you're doing, but it'll make sure all the dependencies are correct, because some of these packages depend on specific versions of other packages, and that can be a nightmare to manage manually. So we do all that, and then it'll tell you when there are updates, and you can, you know, remove them easily, and it's great. So that's part of the training packages as well. And then, of course, we show you how to debug, and there's a Python command line debugger, as well as we provide a graphical debugger for the training. and then help and documentation, right? One of our goals is for you to leave the training able to, answer your own questions and learn more on top of what we've taught you. So we make sure that you're comfortable with that. So all of those tools and more are available as a one-click installation with Canopy. It's the integrated analysis environment that we use for the training, as well as for commercial purposes. And you can get it at this link, enthought.com/product/canopy, if you want to try it out. It's free. All right, so that's the environment. And then, of course, every program has data structures in it. So what's important is that we are very careful to curate out the, say, 20% of data structures and concepts that you need for 80% of the work. And then we make sure that you have the capability to go and figure out what extensions to that you need on your own. So we don't want to cover everything. You can get that from a reference guide. We just really want to, that's part of the way that we manage the scope so that we can spend more time on exercises without cutting topics. Okay, so you need numbers, you need integers and floating point, you need Boolean values for logical operations like true and false. You need strings of characters like hello world or names or whatever. And then more aggregate data structures, the lists, dictionaries, and tuples are most common. So we cover those. And then this is a typical lecture slide. And there are a few points I want you to note here. One is that it's all example-based. So we're not going through abstract syntax and showing you all the parameters, in abstract form. It's like, here's a typical use case, much more accessible, much easier to follow. It's also all executable code. So we encourage participants to type along with the instructor while they're lecturing. And sometimes they'll lecture at the command line so that they can kind of have this ongoing dialogue with the participants. So you can type it in, you can try variations. If you hit something strange, it generates a question, and we encourage that. So that's one other way that we keep you engaged and make sure that you're learning all the time, learning those skills. So the other thing is that this is all executable, which makes it kind of a cookbook later for more advanced topics especially, where you can use it as starters for your own program. And then, like I said, we curate out, so we aren't going to cover all the methods associated with the list data structure. We'll just do the most common. And then, we can put gotchas and things in here. Important points to note for related methods or, things to watch out for. And people report that they love the manual that we hand out because it's better than the reference guide. It's distilled down to that 20% of most useful stuff. And it's all example-based, so it's really easy to figure out how to use what's there. This is just to reinforce that same repeating pattern of now we do the lecture, which is interactive, and then we do finger exercise, and so you would use what you just learned about lists in 3 to 5 minutes or so. We also have more substantial exercises, so we have lectures, we have these kinds of finger exercises, and then we have bigger exercises. So you would do a bunch of concepts or a few units of content, and then we would give you something more substantial that would be more of a real world kind of problem, and that might take these take a few minutes, those might take between 30 and 75 minutes depending on the class. Okay, so on the design and its effectiveness, this is kind of a representative comment. So what this person said, this format of going back and forth between lecture, finger exercise, and longer exercises was extremely helpful to get foundational understanding, which is really what we want, right? Transferable knowledge, and not just copy and paste voodoo programming, but you should understand what you're doing so that you can actually be thoughtful about it. And that's what this person says, is they were able to walk away knowing how to use the libraries and understanding, not just being able to copy and paste and fill in the blanks on the APIs and stuff. All right, so control flow is next. Every program has some logic, so this is fairly standard across languages. We cover if-then statements for conditional, and then looping. If you want to do something a million times with variations, then you need a loop. So there are for loops and while loops, and then there are some special Pythonic looping patterns that we introduce, like list comprehensions. All right, and then if you're going to, a lot of beginners or people who don't have a lot of background in computer science or software, they'll write long scripts and then, to do their analysis and reporting, and then the manager says, give me the same report but daily instead of hourly, and so they'll copy the script and they'll make one little change, and they'll have 100 copies of this script. That's not great. That creates bugs. It creates, it's not reusable. If there is a bug, it propagates through. So there's all sorts of problems with that approach. So you really need to know how to organize your code. And functions and modules are the two kind of biggest bang for your buck there. And so we explain how to use those. It gives you more robust code, reusable, maintainable, you can share it better, and so on. Okay, so that's the Python language module. All right, after that, we get into the NumPy and Matplotlib modules. And those are really two of the workhorse packages for any kind of scientific and analytic computing. NumPy is for array programming, and Matplotlib is for, you can do publication quality figures and also quick and dirty figures, so it's the plotting and figures package. So for NumPy, here's a good example of, in some cases, you need to understand, it helps, let's say, to understand how Python is implemented under the covers in order to make good choices and to write efficient and effective algorithms. So this is a place where we really want you to have some intuition about how the NumPy array is structured and operates. So we'll introduce that and talk it through. And then, similarly with the lecture, we'll make sure you understand the 20% of attributes and methods that you use 80% of the time with examples. And then, we show you how to interact with it. And here's a good place. One of the amazing things about NumPy, if you haven't done array programming, if you're coming from Java or C or C++ and you're used to like handling array multiplication and sums through loops and double loops, this is great because it's just kind of like mathematical syntax. You type A times B, and A and B could be arrays, and it just sort of handles it. So we kind of show you how to interact with that and use it. And then here's another example of a finger exercise. 3 to 5 minutes. Do what we just showed you, and then we'll move on. Okay, and then we get into array calculation. So how do you do the sums? How do you use statistics, variances and things on rows and columns? And then how do I restructure my arrays? Because often, you might have a multidimensional array and you need to take a subset, or you need to flatten it, or you need to do something. You need to reshape it in some other way. So we teach you how to do that. And then Matplotlib, again, this is a place where it's really helpful to have a mental model. So we give you a mental model of the Matplotlib object model. And there are a lot of visualization packages in Python. Almost all of them, I would say, they kind of layer on top of Matplotlib. And so they make things easy for particular use cases. But then if you need to get more nuance and control, or you need to do something that they don't cover, then you're going to drop down to Matplotlib. It also just helps because they use, some of them use similar object model. And then we go through and show you how to make specific kinds of plots, like a scatter plot. We do a line plot, histogram, so on. And we do it, again, through example with code, and we'll walk you through, and these are the most common sort of parameters. And then the thing on the right is generated by the code on the left, so you can kind of see that. And then we give you one of these more substantial synthetic exercises where you just learned a bunch of stuff, and we're going to ask you to apply all of it to make this pretty complicated plot. So it's a really good check on whether you understood a lot of the stuff we just did. All right, so that's typical design. And then we get into Pandas. What's interesting about Pandas is it brings together a whole bunch of functionality that used to be pretty scattered around in different packages. So data loading, cleaning, preparation, wrangling, shaping, some analysis, and then it integrates really well with other packages that do modeling and analysis, like Scikit-Learn for machine learning and stats models for statistics. So it's amazing, and it makes our lives a lot easier, especially for the kind of data preparation phases of data science. So I'm not going to go into as much detail here because I've gone over some of this in other webinars, and I'm going to give you a handout. But basically, we cover data structures, and then the data wrangling operations, and the computations, and then manipulating data. So the data structures are the series in the data frame. We cover those in sufficient depth for you to understand them. And of course the index, which Pandas introduces. For input-output, that's one of the places Pandas really shines, is you used to have to get one package for Excel files and another one for CSV and another for HTML and so on. It'll just read all of those into a data frame. It's really fantastic, as well as many others. And you can write to them as well, to those formats. Dealing with missing data can be an issue. You might want to drop those records, you might want to impute a constant, you might want to interpolate, you might want to fill forward or backward. So there's a lot of flexibility in how Pandas can help you deal with that. Dates and times can be a nightmare. Pandas was developed within the financial industry, where they deal with stock market data and stuff, and so time series, but not just that. I mean, time zones and date time formats that are manifold, and you've got business days versus weekends, and you've got bank holidays, and so it makes all of that stuff really easy. So if you're working with time series analysis, especially where you've got those kinds of issues, then Pandas is definitely something you need to know about. And then, of course, computing with the data frame and the series, numerical operations, statistics, and reshaping the array. And then Pandas is fantastic for data manipulation. So it's got this split, apply, combine kind of capability. So if you wanted to split on gender, for example, male and female, and you wanted to perform some operation or transform on those groups and then recombine into a new data frame with just the summary statistics, you can do that in like a line of code. It's amazing. And then merging data sets from different sources and creating pivot tables and so on. So lots of good data manipulation capabilities. So we have these cheat sheets at enthought.com/Pandas Mastery Workshop with hyphens. There are 8 of them. They cover a superset of what's in this course because they're really tied to there's more content covered in our Pandas Mastery Workshop, or Python for data analysis, and so it's tied to the full scope of that content, but it'll give you a really good sense of what's covered here. Plus, they're handy. All right, so that's the 3 days of the core Python analysis tools. Let's look at the other 2 days, which are really the data science and machine learning. So the workflow here, right, is you get your data, you make sure that it's correct, you pre-process it, you deal with missing values and all that. And then you plan your experiments, and in data science, your experiments might be, you're looking for something in the data, so you have hypotheses you're going to check for. And then you get into model fitting, evaluation, and then prediction, and that's really the bulk of this part of the course. There is some pre-processing and stuff, but really the bulk is the machine learning, model fitting, evaluation, and then predictions. And then, of course, those predictions feed into informing whatever your business decisions are, and that's outside the scope. All right, and you'll see that structure reflected here. First, we cover some. So we already covered how to read a bunch of file formats, but data scientists often are dealing with a lot of data stored in databases as well as other formats, and so we spend some time here giving you a couple of additional tools for reading from SQL databases. We covered DB API 2, which is a standard for interfacing with all kinds of different SQL backends, and SQL Alchemy, which is really nice for a couple of reasons. One of which is it provides a uniform API, so you can just write your code once and flip out the backend, and the code all works. For visualization, we covered Matplotlib. Pandas has some basic plotting capabilities that we do cover, and then there's others like Seaborn, which is really fantastic for data science kinds of workflows. So, for example, you could create this plot in Matplotlib with these 4 panels, right? Or you could use that tiny little bit of code there, starting with vehicles.hist. And you're just telling it basically, I want to cut through my data and I want to look at all these facets, and here's what I want to use for the columns, and here's what I want to use for the rows, and so on. And so these are individual variable distribution plots, and it's just really great because you're looking for structure and you're validating assumptions, and you might have a lot of variables, and so it's one line of code to look at all of them simultaneously. And then you also have different choices for, these are histograms, but you could also do these probability density plots or box plots or violin plots and so on. So if you've got bivariate plots that you want to look at for looking at relationships between variables, then there's nice options there as well. So for example, and they have a lot packed into them, right? So the one on the left, it gives you your scatter cloud, it gives you your best fitting regression line. It also shows you, if you look carefully, you can see it shows kind of a confidence interval there. You get your correlation coefficient and p-value. It's got the marginal distributions. That's just a simple line of code, and you get that, and again, you can kind of facet that. So it's really fantastic. And then, so you have a lot of variables and you want to look at a lot of cuts through the data, but one thing you also are doing is you're looking for relationships, and you don't necessarily know where the structure is. And so you might want to look at a number of variables at a time. This is a 5D plot. It's got 2 variables shown on the columns, 1 on the rows, then the x-axis for each of the plots, and then the color. So you can really do a lot, and then you get the faceting as well. So that's the kind of thing that Seaborn does, which is perfect for this kind of workflow. Okay, so then we get into pre-processing, and so the key here is that machine learning algorithms make assumptions about their data, right? And you need to prepare the data so that it matches them without distorting it. So the topics we cover are outliers, normalizing your data, missing values, and then dimensionality reduction. And we introduce some of the art of making choices around that and understanding what the problem is and how the tools help solve it, while we also are introducing the tools themselves. So for example, this is just one example slide. We need to, in some cases, rescale the data, right, to zero mean and unit variance because the algorithm expects that for its features. So we kind of go through that, show you example, talk it through. Dealing with missing values, we cover some of that in Pandas. It's got great support, but Scikit-Learn has additional capabilities. So we go over that, give you some examples. And then principal components analysis is what we do for dimensionality reduction. And again, kind of explain what is it and how does it work, and then how do the tools operate. And then you might see a demo, and then you might do an exercise on that. For example, this is a good place to show you an exercise. So this is typical of our, like I said, our larger, more substantial exercises. They tend to tap a few concepts that you've covered, and they tend to be more real-world oriented. So this is actually an exercise where you're doing facial recognition. So we would give you the code as setup, and then we give you some exercise questions, and different exercises have a different format. Some of them we have hint buttons that you can disclose or hide. Some of them have the solutions for each step built in so you can compare if you want. This one we just give you the whole problem there, and you're meant to kind of work it out. And we get you to the point where you can see the data so you're not tripping up on things that are just kind of set up. And then you would go through, and the exercise would have you pull out a principal component and then look at the first 12 principal components, and then reconstruct a phase. So this is the original image, and then this is reconstructed with a much lower dimensional representation, and it's pretty good. So that's the kind of exercise that we would have you do after you learned, PCA. Then you just do it. So it's really fun, very interesting. That could take 45 minutes, an hour, something like that, depending on the class. All right, and then we get into the machine learning methods proper. We give you this kind of job aid here, which helps you make choices about what algorithm to use, depending on what kind of data you have and how much. This is not ours. This is from Andreas Mueller, but it's released under the Creative Commons license. So that makes a nice kind of front piece here. And then we get into the actual algorithms, right? So what we cover we cover regression and classification. And regression is when you want to predict a continuous outcome variable, like price of houses in a market given square footage and yard size or something. So those are continuous variables. So we cover linear models, support vector regression, and decision trees. That's kind of a sample of different types, classes of models. And then, ideally there are different sort of actual algorithms within some of those families, and so you should be able to apply what you learned here to those as well. And then we get into model selection and model fitting and evaluation. Like, how do you, there's art to this. You don't just plug it in and get your model out. You've got to kind of work around to find a good model and make sure it is a good model. So overfitting and regularization and bias variance trade-off. So, we'll give you sample code. This is actually a model. It's very concise, as you can see in Scikit-Learn. That's nice. And then we show you the output, and the instructor would, talk through it and show a demo and so on. And then this is a slide from the overfitting section, giving you the intuition about what the problem is and why it occurs. And then we deal with regularization as a method for dealing with that, and some of the trade-offs and the different methods and which ones are better under what conditions and so on. What are the drawbacks? Okay, I'm not going to go and jump over to this exercise, but then, for example, one of the more substantial exercises here would be, we give you the chemical and physical properties of certain wines, and you're meant to predict which ones are going to be rated higher quality by human raters. So these are all chemical and physical tests, and then these are, subjective evaluations by wine experts. So it's kind of a fun exercise, real world, where you might be trying to predict something of value based on the data that are available. Okay. All right, so that's regression. Then we get into classification, and we cover linear classifiers, linear classifiers, and then classifiers with more than 2 classes, maximum margin classifiers, support vector machines, decision trees, and instance-based classifiers. And similarly to what I said about regression is, these are families of algorithms within some of these, and we kind of give you the capability to understand how that family operates conceptually, and then we show you at least one instance. So unlike regression where you're predicting a continuous value, here you're trying to figure out what class is this thing in. So it might be, you know, zip code digits, and you're trying to figure out, okay, that's a 2 and that's a 4, and so you can kind of figure out what category they are. Similarly, you know, email comes in, is it spam or not? That's a classification problem. Face recognition is a huge one now, so on. So lots of good real-world applications of that. You know, typical slide, we introduce kind of what's the idea here for this linear classifier. How do you think about it? Give you an example, and then, you know, then you do some exercises. All right, and then model selection. Just briefly, you know, how do you determine if you have a good model, or if you have multiple options, how do you choose the best model? So we talk about cross-validation as a major method for doing that, you know, along with how does it work and what are the gotchas and so on. Just as a quick example. Okay, so this is a pretty intensive course, as you can sort of imagine, although as you saw with some of the feedback, it seems well-paced and people get a lot out of it. Natural language processing, we often don't have time to cover. But if we do, we cover extracting text features, text classification. So for example, here's a sample of text, trying to figure out what language it is or what kind of document it is, and then topic modeling, where it's like, you know, maybe you're doing tweets or something, Facebook posts, and you're trying to figure out what are they about? What's the topic here? We also have these cheat sheets for the machine learning pieces of the class. We cover clustering, classification, and regression in the cheat sheets, and you can get them at this URL, right? Enthought.com/Python for data science training. And we also hand both sets of cheat sheets out in the course. All right, so we already looked at this feedback. So just to give you a sense of kind of people's overall experience, these are all now, again, quotes from people who took this particular course. So highly recommend if you want to learn or improve Python. Trainer was the best I've ever encountered. That's actually common that we get these kinds of comments about our trainers. It's like, here's another one. Fantastic class. I learned so much in 5 days, and the instructor was excellent. I didn't spend much time on them, but they're amazing. Every instructor we've had to date in the company has had a PhD in some relevant field, science, technology, engineering, or math. All of them have had substantial experience. They're deep Python experts, but they also have had substantial experience in doing this kind of work, scientific and analytic computing, applying it. So they understand kind of, you know, the issues around that as well, not just the syntax. And then they also are all very passionate about teaching, and they all have had, you know, lots of teaching experience. So they're terrific. So just a note on that. And then here's just one final comment. This is probably the most concise data science primer course you can find, 100% worth it. So again, just kind of speaking to, you know, we're trying to use this to validate that our design assumptions and goals have been met. And this is the sort of thing that suggests they are. 95% of people would recommend our courses to colleagues. So we have a very high satisfaction rating. Very quickly, some people ask who are the kinds of clients that you've had for training in the past. So here's a sample. Up at the right, we have kind of financial firms. Up at the left, we have oil and gas, some aerospace. Down at the bottom left, we've done a lot of stuff with the military. In the middle, kind of middle right, we have biotech. At the bottom right, we have a lot of national labs. We do a lot of work there. We've social media. You can see Facebook in there, and so on. Okay, and then product, consumer products. So lots of different fields, lots of different interesting projects. All right, so wrapping up, if you're an individual, you should see our open calendar at enthought.com/training. Here are the upcoming classes. I've highlighted the data science classes in blue, but you can look at the others as well. Typically, we teach them, you know, at big cities, and then cities where there's a lot of concentration of people who need these skills. And if you want more information, or if you've got a group of people but it's not enough for an on-site of your own, you can request a different location, and we'll see if we can accommodate that. So just reach out to us through this training, enthought.com/training. There's a contact form there, or you can use these contact information as well to get to our account executives. So also, if you have a group, you should definitely talk to one of these folks, Brian or Michael. They can help you figure out what what your needs are. They can help. Well, they'll talk to you about what your needs are, and they can help you figure out what might be a good fit in terms of the course, and all of that. All right.
Okay, so I think we will sign off. We'll be following up with an email with both the recordings and links to both cheat sheets that he was talking about. And appreciate everybody coming in and attending today.
Yeah, thanks for joining us.
Thanks so much.